Okay, here we're on to section 9.4 where we're going to talk about vectors. And vectors is actually an application of all this polar stuff that we've been doing. So why are we doing all this polar stuff? The good news and the bad news is that we're stepping out of our complex plane. We're back to our normal plane, but we have certain letters that we use to designate as the x-axis, the y-axis, and even the z-axis. So I'll be introducing those to you as part of this, but let's go ahead and get some definitions down. All right, so the first thing we need to know is that a vector has both a magnitude, and that's your value. We also called it a modulus, right? And it has a direction. So there's a value to it, and it has a direction. For example, if I'm at the zoo and the ape exhibit has had a breach and they are out of their cages. Not only do I want to know how many apes are loose, I want to know what direction they're running so that I know where to go, right? So it's important to know both the number and the direction. Okay, from a geometric point of view, vectors are represented by directed line segments where the length of the directed line segment is the magnitude, and the direction is from P to Q in the example below. Okay, so this value tells you how big it is. So if I have a small vector like this, that's going to be a small value. If I have a very, very large vector, it's going to be a large value. And this direction is really our angle, right? So I could have a small vector heading to quadrant 2. I could have a large vector heading south, right, at 270 degrees with a certain magnitude, let's say, 15 meters per second. So all of these vectors have both that value and a direction, okay? Here we have vectors below are equal because they have the same magnitude. So if you look, it's 1, 2, 3, 4 over and 3 up. So 1, 2, 3, 4 over and 3 up. 4 over and 3 up. So that value of this vector, right, whatever these units are, they are all worth 5 and they all have that same angle. So they're all equal to each other, okay? When we describe a vector, we have, well, actually, let's go ahead and get this down. And the same direction. Notice that where you start and where you end does not define the quality of the vector. So, right, P is starting somewhere here on the grid, R is starting over here. That value, no matter where you start, that point is irrelevant because your vector value is still going to be the same value. We call this its initial point, and we call this the terminal point. And then you'll notice that it has this arrow here, and this shows the direction that the vector is going. Sometimes they call this the tip of the vector, and then of course your initial point would be considered the tail of the vector. So I'm going to put that down. Sometimes they call this tip and they call this tail. So if you hear me saying put your vectors together tip to tail, I mean that you're stacking your vectors one on top of each other. Okay, so terminal point is the official name, but we call that the tip, and then the initial point, sometimes calling that the tail. All right, so let's go ahead and take a look. Vectors are denoted with a bold character or written with an arrow over the top of the letter. For example, in the graph below, the vector is called V, which is bold, or we could say V with an arrow on the top. Now you can do a double arrow, or I should say both sides of the arrow. Often we just use one side because you don't want to encroach on the actual letter. This is just from a practical standpoint, and I don't know if if as we go through the notes, they're going to have a different way of designating that. All right. Okay, so to add vectors v and w, you draw vector v, and from the terminal side, or a terminal point of v, you connect the initial point of w. The sum of these vectors is the vector whose initial point is v and whose terminal point is w. So we have, here we have v plus w. Let me explain how I would do it, right? So you have v, and you go ahead and graph that v. From the tip of v, you put the tail of w. That's what I mean. So go tip to tail. So your initial point is actually your initial point of w. Your terminal point of this vector here that you made is the terminal point of w. So that's what this means, right? Your initial point, terminal point of v connects with the initial point of w, and then when you put the sum of the vectors. So essentially, this v plus w, you're taking all of your x values here, and then all of your y values here, and that new vector becomes the hypotenuse of the triangle, right? So you're just looking at your x and y components as we go. And I'm going to have a activity for you guys to do that's going to help make things a little bit easier. So this is page 1. I'll pause here and you can continue on for page 2.